All right, we're locking the doors because now's the time that you guys got to do some work, because you guys have learned how to design and implement studies, but now that you've learned it, it's time for you to actually do it. So, quick reminder, this morning you went through several interesting questions of various sorts. And you guys were thought about comparative effectiveness questions about cancer and diabetes and treatments associated with genetic variants. But ultimately, we settled on this question about non-small cell lung cancer and a drug, Nivolumab. And so the question that was raised by Paul was actually, there are two considerations for a first-line therapy for patients who have non-small cell lung cancer. One is carboplatin, and another one is nivolumab. And so the question would be, could we compare those two treatments to determine whether or not they have a differential effect on mortality? And Paul had suggested we're going to look for 2 years following initiation of treatment. So as you've gone through in your class, we're going to get into all the analysis design choices. But the first things first is we actually need to nail down exactly how are we creating these cohorts appropriately, so that we know that we've got the populations correct for our analysis. So I wrote down in words here what I heard from Paul this morning, which is patients with non-small cell lung cancer who initiate nivolumab. And what I've drawn here is a patient profile, just a cartoon schematic that I want to use to make sure that we get our rules correct, because there's some ambiguity in this statement here that we need to clarify. So, first things first, I'm going to make, and Paul, I'm going to need your help since this is your study. I'm going to assume based on this statement that when we say initiate nivolumab, that our index date is in fact the date of the initiation of the drug. So here's our index date that I'm going to just put on this picture. And we're making a statement that the patients have to have non-small cell lung cancer. So already here I've got some ambiguity. When does the lung cancer have to happen in relation to the drug?
Before.
Has to happen before. Okay, that's good. That's good. So it has to happen before we have to observe some sort of non-small cell lung cancer. How far before? All days before. So if someone had non-small cell lung cancer diagnosed 15 years ago and never had it recorded again, and then they magically show up and they take nivolumab, we're going to count that as someone who's going to qualify for our study?
Yep.
That's okay if that's what we want to do. I just want to be clear. Is that the conscious choice we're making?
Well, I think that might be less of an issue of, do you want this to be the first line of treatment or the second line of treatment?
Beautiful question.
Or like, I think it would be okay if it's 15 years before, if they've never been treated before, because maybe 15 years ago it was, I don't know, slow growing.
Mm-hmm. Yeah, I'm actually, just to be clear, I'm not asking this question to challenge a choice. I'm asking the question because we need to make a decision. So is the decision to look for lung cancer all time?
Well, I think that kind of first or second line treatments can be contained or refined by applying some kind of criteria later.
Yep. So what I'm trying to get you guys to do is give me the criteria that we are going to use, because that question is actually a really good one. This statement doesn't say anything about this being first line treatment. Although I think in our conversation this morning, there was hints at that's kind of what we were thinking about. So
yeah, in an ideal world, I think we structure this as a line of therapy and have the ability in home CDM to do that. That's coming. I would say for now, let's do it within a year prior to initiation.
Oh no, it was like going with quality measures, maybe like 4 months.
Okay.
6 months.
Yeah, I just wonder what's manifest as a source data.
But 6 months to a year.
For looking for the cancer.
Yep,
So we're going to look back for, pick a number.
365.
there you go. Chris has it.
365 days is when we're going to be looking for this cancer. Now, this line of therapy, are we looking at first line therapy?
Let's just assume, yeah, I don't know what we're going to find in the data.
Okay.
My buddy Rasham's wrong, she knows this space better than I.
Okay, so if we're going to augment this and we care about first line of therapy, that means we need to add some inclusion criteria that is going to remove people if they've had some other set of treatments. Okay, so we basically are going to be saying, as of this moment, we're going to look back all time prior, and we are going to say you have to have exactly 0 other non-small cell lung cancer treatments. Can we agree to that? Because if they don't have any other treatments, then that probably means this is the first one, and you've got, yep, go ahead.
Oh, no, sorry, can we just clarify the look back period? In the 365 days prior, the patient has to have had a new diagnosis or the first diagnosis? Do you guys see what I'm getting at?
Yeah.
Great question. So what I just wrote down was that we just need to see an occurrence in the last 365 days. But you're asking a really good question. Should it be first occurrence should it be their first diagnosis in the 365?
Yeah.
Okay, very good, excellent. So we're going to look for the first cancer code in the last 365 days. Excellent. Okay. I'm sorry, I can't hear you. Yep, so we absolutely are going to have some required continuous enrollment. How would you, I heard you suggest at least 365. Do we want to use that as our target? Yeah. Okay, so we want at least 365 days of continuous observation. Okay. Any other criteria that we might want to consider to make sure that we've got the population we're interested in? One that I see come up a lot in oncology studies that we do is trying to isolate that we're actually dealing with a primary and specific cancer. So very often we would do something like exclude people who have any other cancers except for skin cancer. So we usually end up getting like malignant neoplasms except for squamous cell carcinoma would be an exclusion. So usually I would do something like go all time back, and I would say exactly 0 other malignant neoplasms. So, and actually, I drew that, but I'm going to actually amend my drawing. The way that I typically do this, and I'll show it just as a way of showing you how cohorts build, is we have one cancer that we need to have, which is that first non-small lung cancer. So what I'll usually do is I'll find that date and I'll say nothing before that. Okay, so I'd anchor on the lung cancer, and I'm saying that lung cancer is going to be your first cancer, so that there's no ambiguity there. The consequence of that, just to be very clear, is you've got 365 days. Let's play out a scenario. Day 365, you got a diagnosis of non-small cell lung cancer. Day 180, you got a secondary cancer of a different sort, liver mets or something like that. Then you get this drug, Nivolumab. Is that an okay situation, or would we not want that situation? Do we want these people to truly only have, at the time that they're getting the drug, only lung cancer?
Yeah.
No disease progression, yeah.
Okay, so we could do it this way, but it sounds like we might actually want to do it this way. Make them clean except for lung cancer, okay? Any other criteria that you are thinking about as it relates to defining this population?
How about life expectancy?
So there's a lot of confounders with regards to mortality risk that we probably want to clean up.
So let's dive into that a little bit. So you say there's lots of confounders that we want to clean up. So we're going to run a statistical analysis that is going to make our our target and our comparator group as similar as possible on all baseline characteristics, which is to clean up confounders, so long as that they're observed. But sometimes there are factors that, to take the idea of like life expectancy, like if someone is in a hospice one day before they got the drug, would you want to have them in your study or not? Right? Like, so that's just as a proxy of life expectancy. If someone is immediately in hospice, is that something that you would want to consider? Those are the things you should think about. And it's not about that they're confounders. It's actually about that there is a subset of people who is not who you are interested in studying. Does that make sense?
Yep.
So are there any of those that you'd like to kick out? Or should we keep them in for now?
I guess related to what he said, are there any chronic conditions that might affect the selection?
So I was thinking the same thing, but I think Dr. Ryan's convincing me that the secret sauce of the methods will take care of that for us.
Yeah, so that's right. So if you're saying, well, geez, I'm concerned that nivolumab versus carboplatin, that there's going to have a different baseline cardiovascular profile, well, that's exactly what the propensity score is supposed to do for us, is make sure the groups are similar in terms of their cardiovascular profile. So that problem, the method should solve, or the method will give us a diagnostic to tell us whether or not we can make the groups similar. So I wouldn't exclude on that. Instead, I would say, do you want the effect estimate amongst people with a cardiovascular event or without a cardiovascular event, or do you want it with both of those groups combined? That's when we're writing our criteria, these would be things to basically define the subset that we want to produce our effect estimate for.
If the methods work, I think of our real-world representation is interesting.
Yep. So you're okay with this one, Sora? Chris, you got an idea?
Is there a benefit of looking at the intersection of the contraindications to the two treatments such that even if we did leave both groups in, you still potentially have one group that is controlling for these two contraindicated things while the other one is not? Is it worthwhile to think that maybe we should also remove those contraindications that would be consistently applied across both groups?
So are there any contraindications for these drugs?
Oh, yes. I'm not the clinician, so I wouldn't be able to dive deeply into that, but yeah, you raise a good point.
If it's complicated, I would throw a suggestion.
No, it's not about, it's a very good comment to make. And in general, yes, if you know that this treatment is not given to a particular group and the other treatment is given to that particular group, well, that violates that idea of the counterfactual. So in general, we are looking for the intersection. And if we know that this drug isn't given to one group but is given to the other group, it would make logical sense to exclude those people at the cohort definition time, because you know that that's not the people you're interested in studying. So it's a really good point. I can't speak to the contraindications of these two drugs, though, so I rely on your team's expertise. Or for now, we could have it as a placeholder, that the idea that we would want to exclude them if we knew what they were. Okay. Anything else? Okay. So this is our target definition now. So we've gotten from this words, we now have this schematic that we can that we will build in Atlas. For our comparator group, what change do we have to make to this picture?
Drug exposure.
Drug exposure. So the only thing that we should change is that initial event should just be switched from nivolumab to carboplatin. And this is actually important because if we're trying to actually model that counterfactual experience, you actually would like for the two cohorts to be identical in every other characteristic except for just the treatment, because the thing that we're trying to actually measure is the difference between the treatments. Okay? So that means we've now defined our T, and we've defined our C by just swapping this out. And what our O is mortality. I probably don't need to draw a picture to give you a sense of what that looks like, or do I? We're going to look for a record in the death table, and that's going to be our outcome. So we've got our T and our C and our O. We've got to create those cohorts, and then we're going to go through, once we've created those cohorts, we're going to go through the process of making all the analysis choices with those cohorts. Okay, so if you want to, so I'm going to do this in the demo environment that you guys have been playing with. You are welcome to do this alongside me, or if you just want to watch, I'm going to make, that's way small, isn't it, huh? Martine, tell me when you can see it. Okay.
There was a nice comment earlier about diagnostics along the way, and one of them was just build your cohorts after you've designed them to see if there are patients.
Yes, indeed. That's where we're going to start here. And I'll just tell you as a related aside, but my team will tell you that I become annoying about this. I always start with a magic marker in my hand whenever I do any study. I don't start by writing code and putting things in Atlas. I start with a whiteboard or a flip chart, and I draw pictures like this. And I find every time that I take the shortcut and I don't draw that, I screw up when I get here. Because there's thinking about getting the study design right that you just need to go through before you kind of transition into the start of the implementation phase. So I always would encourage you to be drawing a picture on a piece of paper and then looking at that piece of paper as you now go say, now let's go represent that idea as a standardized cohort definition. Okay, so just as full disclosure, we're going to go through this full study here this afternoon. I did go in the back room just to get a few things prepared to save some time as we go through this. We're going to build these cohorts from scratch, but just so you know, one of the things I put in here as a expedient was I created concept sets for most of the things that I think we're going to need, just so we don't have to do full-fledged vocabulary exploration for everything that we're going to do here. Okay? So, I'm going to create a new cohort. And actually, just let's see, like some of you have a laptop up and some of you don't. Okay, so is anybody going to be doing this while I'm doing it? Mitch is going to do it, and you're going to do it? Okay, great, awesome. And everybody else, you're going to be watching? Okay, that's totally fine. Okay, I just want to know who's doing, so I'll know what to watch when you guys are going. So I'm going to create a new cohort. I just was on the front page, clicked Start New Cohort, and this is going to be our OHDSI 2019 PLE Best Estimation Ever. And this is new users of Nivolumab for non-small cell lung cancer. Okay, and so I need to define my cohort entry event. That is going to be a drug exposure. I'm going to import a concept set for nivolumab. We said that it is initiating treatment, so that means I'm going to say I'm looking for the drug exposure that's the first time in their history. We said that we need to have at least 365 days of continuous observation before this first treatment, so I'm going to set this to 365. And at that point, what I have done by creating that initial entry event is I have drawn this line in the sand. I've actually put what I've checked here. I've found my index date, which is nivolumab, and I've also accomplished setting my continuous observation. So those two things have now been done for us. Okay. So now I'm going to add some inclusion criteria. The first one is that they have non-small cell lung cancer. And specifically, you guys decided that what we're going to be looking for is a first non-small I'm just going to call it lung cancer. We're going to have our first lung cancer in the 365 days before the initiation of treatment. So lung cancer is a condition So I'm going to look for at least one occurrence of lung cancer in the 365 days before. And we want it to be the first diagnosis of lung cancer. Okay. So full disclosure, I know absolutely nothing about lung cancer or any of these treatments, except for what I was able to learn in the last 3 hours while listening to the Hamilton soundtrack. And what I learned is that actually there's a particular interesting challenge with lung cancer specifically, which is that non-small cell lung cancer and small cell lung cancer are not actually distinguished by ICD-9 codes. And so there is neither ICD-9 nor ICD-10, but rather all lung cancers are smushed together in diagnosis codes. However, my understanding is that 85% of lung cancers are non-small cell lung cancer, and that these treatments that we are investigating are for non-small cell lung cancer. So on the basis of that, given that we're seeing a code that 85% of the time is non-small lung cancer, and we're going to see a treatment which is only for non-small lung cancer, that we can probably feel kind of okay that this is going to be acceptable. Okay. This is an interesting issue, and I know, Paul, you're particularly interested in like where's the new stuff from the CDM module, but actually this is going to be a challenge of source data, not data modeling. The data model, our data model and our standardized vocabulary would allow for us to have this level of precision today. It's just that our source data doesn't have the precision that we would actually want to apply to this. And as we think about wanting to do this study across the OHDSI network, generally what my experience has been is it's not about whether the data model can handle it or not. It's actually about whether the source data has it or not. And oftentimes we have to think about, can we learn something given what we know source data is actually going to contain? Yep.
Why do the patients have to have Nivolumab treatment 365 days before the index date?
No, so it's, this is saying, let me go scroll back up.
Yeah.
You're looking at this right here.
Right, yeah.
What this is saying is the person has to be in the database for at least a year before their first exposure to the drug. And the reason for that is twofold. First is we want to actually be confident that it's really their first use and that we're not just getting a prevalent user. And then the second reason is because we want baseline medical history to use so that we can create the covariates to balance the groups. So we need to have some history in the person's record in order to create those features that we put into our propensity score.
Okay, but my confusion comes, well, the patients have to be in the database, right? And then they have to receive involvement at least 365 days before the index date. So in this case, the index date is when?
So the index date is the drug use. So we set.
Comparing Nivolumab versus carboplatin.
So right now we are just creating the target cohort. We're just creating one cohort of people. It's the Nivolumab cohort. We've just specified up here that we index on Nivolumab. We're requiring that when we have that index date, that we're going to look back and make sure that the person was in the database for the full 365 days, at least 365 days before that index date. So think of that as like if you're thinking like a randomized trial, like this is the date that their treatment was assigned. So that's the date we're going to be using. They have to be in the database for at least a year prior to that date. And that's what's going to give us our medical history. Does that make sense?
If you saw somebody whose first record in the database was a Nivolumab exposure, and that was their first record, you wouldn't know. You would think maybe they had that before, but it just wasn't captured in this database. But if you see the person has like some visits and some conditions and some stuff that happened in a year before their first exposure, then you're a little bit more confident that that's the first time they've had it. So the longer that prior required observation time is, allows you to think or be confident that's the first time they've had it. Does they've been in the database a day and they have that drug there, well, they might have had it before, it's just not captured in that database.
Okay.
Yep. All right. So we've got our new user of the drug, and we're requiring that they have a lung cancer diagnosis sometime in this period. So we've just done this guy here. Okay. So now we need to exclude other non-small cell lung cancer drugs. So since we want this to be first treatment, we want to say does not have prior exposure to other small cell lung cancer drugs. Okay? And so we can do that by simply specifying that we can have exactly 0 of any time prior to any set of other drugs we might want to exclude. So you can see I just created a few concept sets just to get started. Based on the guidelines, I noticed that docetaxel, paclitaxel, itazolizumab, those drugs. These were ones that were listed and up to date anyway as the set of treatments. Had I been smart about it, I probably would have created one concept set and put all of those things in one grouping, because I was doing them one at a time. I wasn't that smart. So what instead I'll do is I'll just say, you can't have docetaxel, and you can't have paclitaxel, and you can't have Pembro, which is the main one I think there, and you can't have carboplatin. Now, I'm going to be somewhat pedantic about this for just a second. You see that what I'm saying is can't have had any of those drugs, and this time horizon when we look to say you can't have the drugs, currently I've specified as all time before the index date, but I've put it as 1 day before because I don't know what happens on day 0. So can you tell me, is this study going to be about nivolumab monotherapy, or are we just looking at whatever regimens start on day 0? What would you like to do as your study, Paul?
Let's do nivolumab monotherapy.
Monotherapy. Okay. So I'm going to add that word here, and that's consequential as it relates to this requirement, because it changes this from being a 1 day before to being a 0 days before, because if the person started 2 on the same day, this would be a problem. And maybe a little bit inside baseball, but so Paul, my opinion about some of the things that are going on with the episode table in the CDM oncology module, I like that there's some things that'll be a little bit easier, but honestly, there's nothing that they're doing that you can't already do with the drug exposure table. Like, just doing this allows me to handle any set of regimens I want. It's a little bit kludgier, so it's not quite so elegant, but actually, like, I can handle monos, regimens, combos. We can do it all right here currently. So just as a general aside, like this idea of the difference between first line, second line, third line, we could have done it, but just by toggling these options. Okay, so we've got our nivolumab. They have to have non-small lung cell cancer. They have to not have exposure. And then we said they have no other cancers. Okay? And we specifically decided that that was all time in their history, and it was starting at day 0, or starting at day -1, because they have to have the lung cancer. Okay? So... Okay. Okay, so I'm going to do it this way. What I'm going to need to do, though, is I'm going to have to do a little trick here. So this can be exactly 0. Given that you guys wanted to do it that way, I'm going to just make one switch. So this specifically has to be no other cancers except for lung cancer, because the lung cancer is okay for our particular population. So I'm going to just have to make a quick modification to my malignant neoplasms, which is I'm going to go find the lung cancer code that's in there, and I'm going to exclude that from my list. So I'm going to exclude every possible cancer except for lung cancer. And that way I will be allowing lung cancer to happen, but disallowing everything else.
Can you briefly go over that before one day thing that you did?
Sure, absolutely, while that's loading. So whenever we talk about specifying a time band, it's usually easy in like when we're lazy in our language. Let me just go back to it, actually. Let me save this and go back to it. If I say something like, has non-small lung cancer, usually in language, if we're loose, we just say like, in the last year. But in fact, whenever we talk about a time period, there's a start to a time period and there's an end of a time period. And we actually have to specify both of those anchor points. And what we found in a lot of our studies is that this choice of what do you do on the same day is very important. And in observational data, it turns out the same day matters a lot, because that's usually the day that a patient's at the doctor. That's the day where you see lots of information show up. But if it's on the same day, you don't necessarily know the temporal ordering of the observations on that day.
Okay.
Because it's just a one day where a whole blob of stuff happens. So for example, in this case, if I saw the lung cancer and the treatment of Nivo on the exact same day, because we have prior knowledge, we'd probably say they got the Nivo because of the lung cancer. However, if you didn't have that prior knowledge, for all you know, they got exposed to Nivo in the morning, and then in the afternoon they developed lung cancer. So maybe it was an adverse event of the drug. Like, that doesn't make any sense in that case, but other situations, did taking aspirin cause the headache, or did the headache cause you to take the aspirin? And so this issue of protopathic bias is something we have to be worried about. And as the way the data comes in, when it comes in on a particular date, tends to be a particular challenge.
You just made a modification to that DLC. What was that?
Oh, so I'm sorry.
So you went you said to them, therefore I have to go back and change.
Oh, so yeah. So in this criteria that I'm going to apply, I'm saying that you have exactly 0 of any other kind of cancer. The change that I just need to make quickly is right now that list of cancers includes lung cancer itself. So I have to just remove the lung cancer from that list, which I'm actually going to just do here real quick.
So if you're doing it, you don't have to do it because we're running off the same thing?
Yeah, we're using the same exact thing. So once I make this modification, you can actually, you can do it too. So what I'm going to do is I'm just going to...
But your modification is your concepts that will apply to ours because we're using the tutorial version?
Yeah, we're all using the same exact thing right now. So if I make this change, you guys are going to be good.
Oh, okay. That's all.
So what I'm going to do is I'm going to say exclude that guy, and then what I'm going to say is excluding it and lung cancer. So this concept set now is more specific about what it is. And then if I go into my cohort definition, best ever, no other cancers, I just got to swap out this concept set to say excluding skin carcinoma and lung cancer. Okay. So I now have a cohort of people who have non-small, so if lung cancer, who do not have any other treatments all the way into day 0, and do not have any other cancers, okay? So that's what we've just actually specified in our cohort. And so we now have a monotherapy cohort we can work with. We have to define a cohort exit criteria, whether or not we want to use it or not. But a rational one in this case could potentially be to say, let's have the cohort be while the people stay on nivolumab, they're just in the cohort while they're exposed. In which case we can actually, we can build a dynamic drug era that basically keeps them in the cohort so long as we keep seeing the drug being prescribed, and then when they stop taking the drug, we'll take them out. We could do this however we wanted. If we wanted regimens, if we wanted to stop them when they start some other treatment.
That is, they'll get chemo for a certain amount of time, but not for the rest of their life.
Yep.
Okay.
So this will follow them while they're on the drug,
Okay.
and the moment that they stop getting prescribed the drug,
Yeah.
they will disappear from the cohort, meaning their cohort end date will end when they stop taking treatment.
Okay.
So the study period will be much shorter than a year because then chemo for a year.
Yeah, but we-
Like, hold on.
So yeah, this is an important distinction, which I think you probably went into. So remember, there's a distinction between how long are you in the cohort and how long are we specifying the time at risk of a study. And here, this would allow us to say something like, if we wanted to study an on-treatment effect, now we could use the cohort to do it. But if we want to do an intent to treat analysis following until they're gone, now we have one cohort could support both of those analyses. And so your analysis is going to be an intent to treat for death, but we've created a cohort in case you wanted to play around with it, you could make use of this.
What if the drug is not given daily?
Yeah, so specifically what this is saying is look for drug exposure records, and as long as they happen inside of 60 days of each other, then they will get combined together.
And what we got that patient on the exposure, right?
That's right. Yep. Something like that. That's why I put it 60 because I think that goes 8 weeks at a certain point.
Okay.
All right. So we've got a cohort definition, best ever. Okay? In the way that I tend to do this is now that I've created my cohort definition as an initial feasibility, I could run this cohort definition on any sort of databases. So I would just go to the Generate tab and I'd click Generate, and I'd let this cohort run to see how many patients come back. For those of you who took the phenotype tutorial, one of the things that I say that sometimes seems a little bit counterintuitive is when you create a cohort, you could have a totally valid cohort definition that returns back 0 people. And there's lots of reasons why that could happen, but not the least of which could be this is simulated data that goes back to 2014, or it goes up to 2014, and you guys want to study a drug that was approved in 2015. Okay, so from that perspective, what we've just created as a cohort definition could be totally valid, could actually be a really good definition to go run around the rest of the world, but when this runs, it is going to return back 0 simply because the fake data that we're playing with doesn't support it. So there's your 0. Okay? So maybe a downer that we don't have people to be able to see. I use this very much to inspect, like, did I do something wrong in my definition? I can, in the interest of time, I'll just tell you, like, we didn't do anything wrong because I actually took, do you have this? Are you on VPN right now? All right. Here we go. So here's.
Before you jump off that, you are correct, of course, that we don't have the drug. That 0 could have came from just one rule not being satisfied by everybody.
Fair enough. Yeah. So just clicking this view reports, we can actually see, was it because an inclusion criteria screwed us up, or was it because we actually didn't start with anybody? So in this case, we didn't start with anybody, which is why we didn't end with anybody. But as a demonstration of this, so you guys right now are working in a tutorial environment, but remember, this Atlas software is running everywhere around the OHDSI network. And so now that we've designed this cohort, we can actually just export this JSON expression and just send it to any of our friends in the OHDSI network, and they could actually try to run that study in their environments. Say, for example, Paul's now come up with this study, and he could say, hey, Weaves, could you take a look and see if you could run this at J&J? And Weaves could say, oh, I'll try to give it a shot. And he would just log into his J&J environment. You notice that it's the exact same software, but now I'm locked into a secure environment only at J&J, so you guys don't have access to this. But all I'd have to do to be able to run that is I go to that JSON expression, I take that file that Paul just sent me, and you'll see that I've just, in my environment, I've just now fully defined that exact cohort that you created, and I'd say this is my feasibility to help out Paul. And because I have access to lots of data at J&J, I can say, I wonder what's going to happen if I run that in the UK, and I run that in the privately insured population, and in Medicaid, and in Medicare, and in France, and in Germany, and Japan, and Optum.
The server just called.
So in a few minutes, Weaves would be able to call back Paul and say, okay, yeah, your study, it looks like I could make it work in some databases. Okay? Now, that was our target cohort, but of course we need a comparator cohort. So how do we create the comparator cohort? We just need to switch out our target drug for the comparator drug and hold everything else constant. So how do we do that? We copy this cohort definition, but instead now of having new users of nivolumab, we're going to have new users of carboplatin. Well, so I'm going to save that as my comparator. I'm going to select carboplatin as my target, as my index drug. Remember that I said no prior exposure to other things, so I'm going to have to swap out carboplatin here with nivolumab. And my exit criteria, they're going to stay on this cohort as long as they stay on carboplatin. Okay? So that was less than 60 seconds, and we just created a comparator cohort, okay? We can run that in our database and see, well, geez, we didn't have anybody in our target group, but could we at least run this in our data to see whether or not we actually have anybody who satisfies this comparator group? And to the same thing that Chris was mentioning, figure out, is it the inclusion criteria that are causing us problems, or is it actually the index event that's causing us problems? While that's running, so that'll actually just take a few seconds, but while that's running, I need to create an outcome cohort because we need a T and a C and an O. So I'm just going to create a new cohort. This is going to be OHDSI 2019 best PLE ever. And it is it's mortality, right? We're looking for death. So this one's quite easy. I'm going to say death. Done. That's our cohort. It's just an occurrence of death. That's what gets you into your death cohort. Okay? And I can run and see, do I have any deaths in this database? And so remember, the power of this idea of creating these modular cohorts is I've just created a cohort definition for death, and I'm going to do a study on nivolumab and carboplatin. But of course, somebody else might want to do a totally different study, but still study death.
Once back to the definition.
Yep.
So everything is the same except for the cohort entry events, right? I mean, when you define an outcome cohort, right?
So for outcome, you'll see I didn't even have any inclusion criteria.
No inclusion.
I literally just have, I'm saying, an observation of death.
So
That's all you need for.
It's not like copy and paste thing. You created a new outcome cohort from scratch, right?
That's right.
Okay.
Yeah. So I did a copy and paste for the target and comparator because I wanted to copy over all the rules. But for the outcome, it's totally independent of the target and the comparator.
You're creating 3 different cohorts.
That's right. We created 3 cohorts, a T and a C and an O. And it's important that they're independent because now I want to do this study of nivolumab versus carboplatin until Paul's friend says, don't do carboplatin, do Pembro. In which case, you can do the exact same study design, just swap out your C for another drug. Or someone says, I don't want to do all-cause mortality, I want to do cancer-specific mortality. Well, you just swap out your O and put it in OO. By having these building blocks, you get to put them together in whatever configuration you want.
When you define an outcome mortality, you don't necessarily need to define the date. The relationship between the event and the index date, you know?
Correct. So this is independent. When we do our analysis, when we specify the cohort design, that's when we're going to say, when do we have to observe these death events relative to exposure? But that's an analysis design choice. It's not a cohort definition choice. The cohort is people who died. And the start date of when you enter the people who died cohort is when you died. That's the only thing you should need to know. And you don't need to impose any other constraints.
If our outcome wasn't death, but it was something that could be repeated,
Yep.
we need an exclusion in our exposure cohorts for not having had the outcome before if we were interested in doing that.
That's a very good question, Mitch. So in the, when we go through and make the analysis design choices, you're going to have the choice of deciding, do you want to exclude people who have had the outcome previously? Sometimes you might want to, and sometimes you might not. So we consider that to be an analysis choice, not a cohort choice.
So you could do that in your cohort definition, but now we have maybe 100 negative controls, so you want to create new B and C cohorts for every negative control, or you want to do it, let the computer, the program handle it for you? Got it.
Oops. So let me just go back to,
That won't depend on whether or not I keep only the first event in my outcome cohort definition.
so
Or do I need to keep all in order to allow it to exclude people with a history of the definition?
Oh, so it depends on what you want to do. If you want to, if you don't want to exclude people that had the outcome prior, you can allow them to have the prior and you're going to look for it as the outcome during the risk, and you can say, I'll look just for the first. But if you're going to say, I'm going to exclude them that happened prior, then it makes no sense to have them.
But if you do that outcome cohort, you only use the first one. And let's say that first one happened before, and you're allowing the people to have priors. You kind of created an immortality situation that the only thing in your outcome cohort is their first one.
Yeah.
Then they start their at risk, and you've already said they can only have it once in the cohort, so they keep on going, even though they may have had the outcome again. So be very careful about excluding priors. If you're saying don't exclude priors, make sure your outcome does allow the repeat events. Otherwise, that first one will be the only one you're going to keep, and that could be a problem. I think that's a problem.
yeah. Yes.
Sorry, I have to leave.
This.
Leanne can be the subject.
Leanne is the expert. Okay, it's kind of sad that you're about to hit the climax and you're like, I'm walking out of the movie. It's like Thanos putting on the glove. You're like, I guess it's gonna go. It's like
And super cool.
all right, great.
How do I define an outcome other than death?
Yeah, you could, so the same, using the same cohort tool, you could define a cohort based on any observation. So it could be any condition, any.
Can I define a change from baseline or change from some time of
So you can look for measurement values. Currently within the Atlas tool, we're not providing the ability for you to dynamically calculate changes in values. You could do that you could write code to do that, but the user interface currently doesn't support doing that. Yep. I'm sorry, could you say it again? I couldn't hear you. Cost? Yeah. So we have a cost table. Remember, a cohort is a set of persons who satisfy a criteria for a span of time. So you would have to define what the rule is that you're using for cost. A cohort isn't a continuous valued amount. So you could say something like people who cost a certain amount of money for a period of time.
These two cohorts, they use different drugs. I want to see whether they have that different medical costs. Maybe one drug is not so effective, so this cohort may think hospital much more.
Yeah. We're currently, out of scope for what we're doing now is continuous valued outcomes, which is what a cost variable would be. So that's out of scope of what we're talking about here. Yep. Okay, so you can see that cohort. You can see we started with 35,000 new users of carboplatin, and you can see why they fell out. So actually, only 13% of the people with carboplatin actually had lung cancer in their records, and only 25% had no other cancers. So collectively, that means only 1% of the people that we started with actually got kept in the cohort, okay? So this is important for you to think about. Is carboplatin even an appropriate comparator for nivolumab, given that one drug might be used almost exclusively for lung cancer, and this is a drug that's used for lots of cancers. And this is something we should be thinking about up front because we're going to try to make these two groups comparable. Okay, I spent a lot of time talking about our T and our C and our O, and we haven't even started to design an estimation study. And the reason we took the time on that is because if we don't get the cohorts right, the rest of the stuff doesn't matter. But because we've defined now our T and our C and our O, we can go through the design considerations for the estimation with that problem structure in our mind. So I'm going to go to estimation, and I'm going to start designing an estimation study. OHDSI 2019, best PLE ever, comparative mortality of nivolumab versus carboplatin, okay, in non-small cell lung cancer, okay? So the choices we have to go through, we need to actually make a comparison. The comparison we're going to make, we have to choose our target and choose our comparator and choose our outcome. Well, that's the exercise that we just went through. We created a target cohort, which was nivolumab. We created a comparator cohort, which was carboplatin. And we created an outcome, which was mortality. So these are our T and our C and our O. Now, as Martijn and Weaves and Alex went through with you, what you also need to do is define some negative control outcomes, which I was remiss to not actually prepare up front. So what we need to actually do is we need to define some collection of events that could occur that we do not believe have anything that's causally to do with either nivolumab or carboplatin. I'm just going to save this. No, so what we're looking for is some event that would be observable that we can a priori specify is not causally associated with these treatments. And so we want to create a collection. So for example, Martijn, you did the ingrown toenail example. So ingrown toenail. Does nivolumab cause ingrown toenails?
Okay. So
Does
negative outcomes. Okay.
Negative outcomes, yep. And so if we could define a set of negative outcomes, then we could put them into the tool. And actually, I'm in the interest of this, just in the interest of time, I think there is a set of negative controls here. I'm not going to verify that those are actually good negative controls for these drugs, but the idea is you have a collection, which I'll show you what they are here. There is a list of negative controls. In this case, there's just one in this list, plantar fasciitis. Can we agree that nivolumab and carboplatin don't cause plantar fasciitis? If we're good with that, then this makes for a good negative control. Because if our method tells us that there's a difference in plantar fasciitis, well, we know that we've got a biased method. Okay? And so you can actually create as many negative controls as you can identify and use them as your diagnostic. Okay? Going back here. Okay, so we've just specified our target, our comparator, and our outcome, and our negative controls. So the next set of choices that I have to make are my analysis settings. So we'll go through these one by one. So one thing that you could optionally do is specify a calendar time for the span of time that you want to examine your data. Now, in general, I think that it's a good idea for us to be using whatever data is available. And so being able to actually use all of the data can be a good thing. However, there could be some reasons why there's some logical boundings to this that you might want to specify. Like, for example, if there was some sort of exogenous event, like maybe there was a day that the FDA issued a strong warning saying, don't use nivolumab. Well, you would expect that that would have a major impact on your study, and you might want to analyze things only before and after that moment. Okay? For now, I'd say that we could probably just use all the data we have available. Now, the next question that we get asked is, should only the first exposure per subject be included? Now, it happens to be, in our case, that our target and comparator cohort are already new users. So we are already limited to first exposure. But the reason that the tool is asking us, should we limit this, yes or no, is because the tool doesn't know, or the estimation tool doesn't know how you define your cohorts. For all it knows, your T has multiple recurrent events. Because that's something that you could have done different ways in your cohort, your analysis is going to require you to make a specification. And so here, it turns out that yes, we do want first exposure, and that was already handled, so we'll just handle it again here. So if we want to have first exposure, then we have to ask the question, well, what do we do with people who are in both the target and the comparator cohort? So imagine, in certain circumstances, that a person could qualify for both the target group and the comparator group. In our specific situation here, we actually determined that this can't happen because our new users of nivolumab can't have carboplatin, and our new users of carboplatin can't have nivolumab. So in this case, this scenario can't take place, but again, the estimation doesn't know what your T and your C are. They're just asking, how do you want to handle this situation? And this question comes up actually quite a lot in various studies because it is quite common that if you're comparing two treatments, that there are some set of patients who try both treatments. So we need to decide how we want to handle that, and the options there are to keep them in both groups, keep only the first of the two cohorts that you enter into, or you could say if someone's in both cohorts, there's something funky going on and I'm going to remove them. Okay? The next question we have to ask is, do we restrict the analysis to the period where both exposures are observed? And this is actually quite significant, particularly as it relates to drug exposures of products that enter the market at different periods of time. Remember back to Weaves's early presentation of the counterfactual, where you want to replicate the idea that a person had a conscious decision at a moment in time and he hit that fork in the road and he chose blue pill or red pill. Well, if we're dealing with two treatments and one of them wasn't on the market yet, then that means they're hitting a fork of the road where there's only one path forward. Right? If only the blue pill is available, then you don't have the choice of the red pill. So this option to restrict analysis to the period when both exposures are observed, this is basically asking the question, do you want to limit yourself to when all the patients actually had the choice of both treatments? And in general, we think that it would be a good idea for you to do that, though there may be circumstances where that is not necessary. So in this case, I would recommend that we do this because we know that nivolumab is a more recent therapy, and carboplatin is kind of the standard therapy that's been around for quite some time. So then we need to ask the question, well, what's the minimum required continuous observation time prior to the index date for a person to be included in the cohort? This is how much medical history do we need in a person's record prior to their entry to either T or C. And on our picture, we actually said that this was 365, and it happens that we already put that 365 into our cohort definitions. But the estimation tool doesn't know that we did that, and it could have been that we had two different time windows for T and C. And this provides us the assurance that we're following this consistent rule across both cohorts. The next option has to do with sampling your data. So depending on the study that you're doing, you may actually have an extraordinarily large amount of data that you're working with, in which case you might want to just sample some subset of the comparator group when fitting your model, and you can see that there's a range of options. In general, unless you actually have some sort of real computational problems, we generally advocate that you don't need to do the sampling. You then have a question of remove subjects who have had the outcome prior to risk window start. So Mitch, this is your question here. So this is the question of, okay, if a person belonged to the O cohort before they entered the T cohort, how do you want to handle them? Again, in our specific question, our outcomes mortality, probably they did die before they got their treatment, but the estimation tool doesn't know what your T and your C and your O is. In some outcome cohorts are recurrent events. So like the room next door, actually, they're doing a prediction study right now on GI bleeds. And the outcome cohort is actually each individual hospitalization due to a GI bleed. So that outcome cohort has multiple events per person. And so they actually have to be very careful to say, what about the people who have had a prior GI bleed? And how do we determine which GI bleed we're going to be looking at? Okay? So we need to decide what we would do with this. And this is just changes the question. Are you looking for people who have not had the event? Or are you looking for people who may have had the event and possibly previously having the event serves as a powerful predictor of future recurrence of the event? If you do say, yeah, I want to remove people who have had the outcome, then you additionally have to specify, well, how long back do you look to get rid of people? So in this case, we're going to say, if they ever died in the past, let's get rid of them, which hopefully wouldn't happen too much. And then we've got another parameter here, which is now we had that situation. What if a person is in multiple cohorts? So they're in the target cohort and they're in the comparator cohort. How do you actually want to handle the fact that their time at risk might possibly overlap? And we provide the option of how we would handle the censoring in this particular situation. Now, in this particular case, we know that our cohorts are mutually exclusive, so this parameter wouldn't apply to our specific situation, but it can apply in the more general sense. Okay, so we've now just specified how to basically pull in our T's and C's. We now need to specify the covariates that go into the model. And deliberately, what Martijn has, I think Martijn went through in his presentation, is we recommend that you're applying large-scale propensity scores where there's no reason for you to be making subjective choices about the 5 or 10 or 20 variables that you're going to put into a model, but instead you can think about trying to let the data balance itself and on as many characteristics that are important. So deliberately on the user interface, all we're saying is you have the option to include variables and the option to exclude variables, but if you touch nothing, you're going to get a default analysis performed that does the best practice that Martijn advocates for. Just so you're aware, there's this little tinny link up here which I could click on. And if I did, it'll actually expose to you all of the covariates that are available for selection. And the ones that are checked, these are the default set that we typically run. And so if I, for whatever reason, needed to make a change, I could go in here and I could say, I'm not going to study race ethnicity. I'm going to only be interested in not overlapping drugs, and I'm interested in all-time prior. So I could make changes if I had to. Again, our general recommendation, though, is if you don't really know what you're doing, it's okay to just use this default set, which our experience has been provides a really good set of baseline characteristics to use and provides us strong assurances that you get baseline characteristic balance as a diagnostic. Okay? There's your analysis. We now need to specify time at risk. And here you can see that just like with all of these time horizons, we need to be able to specify when does the time at risk start and when does the time at risk end. So in this particular context, we're initiating therapy. So if someone dies the same day that they initiate therapy, do we want to count that event, Leanne? They start on nivolumab and then they die that same day. Would they count, or are we? Okay, so day 0, that doesn't sound good. What if they die the next day?
I mean, could you like a burn-in period, or?
So that's the option that we have. So
Yeah.
is there a period of time that it's not, that you would not consider truly at risk?
I don't know, like definitely within a first week, I think.
We don't trust deaths in the first week. So what we could do is we could say,
Normal criteria for that, definitely not in the first week.
okay, so just to show how it would be done, so we could say our time at risk starts 7 days after the initiation of treatment. And so that's giving us our anchor. So even though we're anchoring here on the index of when they start, our time at risk is now going to start, time at risk is starting at 7. Okay? So that's okay to have a gap of time. And this is why it's very important that when you're creating cohorts, you want to think about when do you enter a cohort, when do you leave a cohort. But when you're thinking about time at risk is a disjoint period of time that doesn't have to correspond exactly to your cohort entry and exit. Mitch.
So if somebody does die on, say, day 4, or let's say a lot of people die on day 4, are those people still going to be in my table 1? Are they still going to inform propensity score models?
It's a great question. So one of those choices that we just had to make up front is, what do you do if you had the outcome prior? And so actually, Martin, I'm going to need your confirmation on this, but that outcome prior is really prior to time at risk start, right? Not prior to exposure start.
Yes.
Yes. So if you make the time at risk 7 days and you said exclude prior events, then people who died before the 7 days would be removed. Okay. So we've got 7 days is the burn-in time, as you said, and then we're going to follow them for some duration. So what is the time at risk that we're going to look for deaths?
You say like a year? I would say.
A year.
Yeah.
I forget. Was it?
It was a year, right? 1 to 2 years?
If only we had written it down on a piece of paper, right? What did Paul say? He said 2 years.
2 years.
Okay. And actually, I'm going to leave that one up there because he said 2 years and he said logistic regression, but since he's left the room, we can talk bad about him. 7:30 is 2 years, and I'm going to specify this as from the start of the drug, okay? So even though we specified that the person was on the drug for some period of time, we're not actually using the length of time that they're on the drug at all. Again, this is supporting the idea that the cohort definition is independent from the analysis specification. Okay. We can then specify a minimum number of days at risk, basically to ensure that someone at least gets to day 7 in this particular case. And so if we specify 1 day at risk, that basically means you got to make it to day 7, or I guess day 8 really. You got to make it to day 8 in order to count in the analysis. And so Mitch, to your question, this is another way where you could get rid of people, because you could say, well, if you didn't make it to the start of time at risk, you're out. So this is an additional way of handling this prior event. So you could say include prior events, but exclude people who don't get into the time at risk. Does that make sense?
Yeah.
Okay. All right. So we've got our time at risk. So now we have to decide, how are we going to make the nivolumab group similar to the carboplatin group? And so we're going to use propensity scores, and we've picked our covariates, but now we have to decide how we're going to use our propensity score model. So we've got choices. We can either match, or we can stratify, or we can weight, okay? And did you show them, Martine, that weighting's a bad idea?
No.
You didn't, okay. So, so we have some empirical work that informs an opinion about this. But for right now, let's just say we've got 2 options. Do we want to match or stratify? Match. We've got to vote for matching, okay? So if we're matching, we have a series of choices that we then have to make about what to do with the matching. So we could say, for example, well, how many people do we want to match? For every nivolumab person, how many carboplatin people do we want to try to match to? So if you do one-to-one matching, then that's kind of like a randomized experiment where you could just look at the observed effect afterwards. If we do 1 to n, one variable ratio matching, 1 to n, then it means you could actually bring in more data, so you could have more sample in your comparator group. But the consequence of that is that you have to do a conditional outcome model to handle the fact that you have these imbalanced match sets. So how do we want to handle that? We have to like do one-to-one matching?
Yes. Yep.
One-to-one matching, okay. So we're doing one-to-one matching, so just going to select one, okay? In addition to that, we need to be able to define if I'm going to create a match, how close do these two propensity score values have to match each other? Our default parameters here is what Peter Austin recommends. So this 0.2 caliper is how we handle it of the standardized logit. Though there's other options that are available if you really care about that. If you don't know what those things mean, then just use the defaults. The next parameter is to decide how much data you're actually going to use to fit your propensity score. We've done some empirical result to show that after you get past a few 100,000 patients, there's not really much massive change in a propensity score model. So it's okay to sample if you have really, really big data. That's not going to be our problem in this case, so we're okay with that. And then there are parameters here associated with some technical diagnostics that will be reported out from the system. There's a check to make sure that every covariate, if there's high correlation between covariates and treatment assignment, that might actually cause us instability, so you can check for that. And also, we can configure the code to make sure that it stops if it hits an error. Okay? You'll notice that there are these bars with a little arrow that nothing is showing, and that's because these are parameters to the model that if you don't know what they are, you probably could just ignore them. Just to show you, if I clicked on these boxes, some additional parameters will pop up. These are all described in the Book of OHDSI or in the vignettes and the practice, but if you don't know what these things are, then it's okay for you to just trust that the defaults are kind of the standard that pretty much everybody uses. Then last but not least, we just need to define an outcome model. And here, Paul suggested that we should do a logistic regression. Okay, and we could do a logistic regression because, and if, let me just to pick what Paul selected. So we could do a logistic regression, and what we would be doing is we'd be saying, amongst the people on nivolumab compared to the people on carboplatin, what proportion of them died in the 2-year horizon? The challenge is that not everybody in these cohorts necessarily makes it all the way to 2 years. They might leave the database, or they may be gone for some sort of other reason. And the longer the time horizon you go out, the more you're concerned about your analysis being subject to the fact that people have differential follow-up. And when you have a situation where you have a longer time horizon and differential follow-up, that's really when a Cox proportional hazard might actually make more sense as a modeling option. It changes the question from what are the odds of death, which is what the logistic regression would give us, to an estimate of what the hazard ratio is. Though in this particular case, we probably are interested in time to death as like the primary thing that we'd want to look at. So in my opinion, a Cox proportional hazard would make sense in this context. So I'm going to overrule Paul since he left anyway, and we'll just say we're going to do a Cox proportional hazard model here. And when we specify that, then we have to make choices about each model that are specific to those. So for example, we are doing matching, so we have to decide, are we going to run a conditional model that takes advantage of the match sets, or is it going to be unconditioned? And so that's an option we have. If we were to have done variable ratio matching, then it is a best practice / requirement that you would do a conditional model.
I think the version of Atlas again, you can bring it up anymore, because
Yeah, so while we see it done sometimes, it's not a good idea. When you do one-to-one matching, though, you actually have a legitimate option. Since the groups are matched sets, you could do conditional model, but you actually do not have to. And Martine's latest work suggests that actually doing one-to-one matching with an unconditional model seems to actually achieve the greatest power and stability for what we're looking at. So while you have both options here, I would say that since we're doing one-to-one, we could do an unconditional Cox proportional hazard model. We have to make a choice of whether or not to use the covariate matrix in the outcome model, which that doesn't actually open up any other options. In this particular case, where all the work's happening is actually in the propensity score. That's what we're doing to actually balance these groups. And once we get to that point, we're basically running a very, very simple outcome model. The outcome model is just time to death between the matched sets. And so there's nothing else that we're actually going to necessarily have to adjust for. But just for the interest of completeness, you can actually see that had we wanted to adjust for covariates in the outcome model, we could have had the ability to do inverse treatment weighting or to actually specify additional covariates that would enter into that outcome model. Okay. There's additional parameters down here for full transparency that you could investigate that have to do with how you're tuning that large-scale model. In this particular case, remember, we're running a two-part model. We're running one model that is predicting treatment assignment, and that is using a large-scale lasso regression. That's using the Cyclops package that Mark developed that we're using for that. And then the second model is a Cox proportional hazard model that's also using the same large-scale regression package that Mark developed. So we're running two different models, but using the same technology that that's been developed in the community and led by Mark and Martine here.
Do you have to worry about proportionality assumptions?
Good question. Yeah, so one of the standard outputs of the Cox proportional hazard will actually be the Kaplan-Meier plot, and so you can actually visually inspect to see whether or not you have proportionality. In addition, we can think about additional diagnostics that you would run on the resulting data set to investigate and inspect those kind of issues. So that would be something you would do once you've executed the study on your data set.
Okay, and in addition to the plot you get out of the likelihoods, you get the life table out so you can actually do the diagnostics on yourself. Like, if you get more than just a plot, you can actually get the data to produce a plot. Okay.
Yeah. So,
like log.
so we don't currently report out the proportionality assumption test. Correct? Yeah, that's not actually outputted, but the data set you could use if you wanted to run that test is produced. Actually, that might be something just to capture as we could probably just output it.
The same way that we look at that data model of the results that comes out of the estimation pattern.
Yep.
So there's that result set. That's the shareable thing you can send around. But also, cohort method creates as output all sorts of data artifacts that are used as steps along the way in this entire pipeline. And those are also saved locally to a computer that you can then drag up and do everything you want with, including those, any statistical test for any assumptions you're concerned about along the way. And that there's like tribal knowledge in there, and that you need to kind of know what the various artifacts are. But it's like all of the data that is created at every single step along the way, start to finish, is saved on your computer for you to access.
But it does for proportionality assumptions, just we don't have to do this for.
Oh, is it? Okay. Like, no, because I'm thinking like, well, if it's not there, like you could always take the data, modify the shiny code, right? And then you can have it output as one of your outputs to your shiny assay.
Well, in this case, because you're actually, for that test, you actually need the basic level data, so you can't do it on what's exported, but it's the intermediary files, they do exist, but they're only locally. So,
Oh, okay.
so somebody else would send you their data, and you no longer compute that test.
It is a community. Anyone who wants to contribute that solution is welcome and encouraged to do so. So just going back to this full screen, so you can see we went through the process of selecting our target comparator outcome. We selected our negative controls. We then went through the process of defining all of our analysis specification. I just gave it a name so that we can remember that it was a 1-to-1 propensity score matching with a 2-year time at risk in a Cox proportional hazard model. And just because we were talking a little bit, we were down at the bottom of the screen. There was nothing else there. So that was the final step, was selecting the outcome model. And then last but not least is we just need to be able to specify how are we going to evaluate that our method is producing the right results. And this is by basically specifying how are we going to use those negative control outcomes to create cohorts that we're going to test our method against. And we have the choice of how to handle that and whether or not we want to do positive control synthesis. So we've just saved this. You guys, we have just defined a study that we can run across the OHDSI network. Yeah, we should clap for that. That's good. So to understand what that design means, not just that we click through a form, but in fact you can actually read and review everything that we've decided on. In this particular case, we chose to do 1 target, 1 comparator, 1 outcome, and 1 analysis specification. However, deliberately the way we develop this tool is you might want to study multiple targets and multiple comparators and multiple outcomes. You might want to make multiple analysis decisions. And through that one interface, you can actually create all of those combinations, and your one study could actually be a compilation of a series of analyses. And in this case, we've just chosen to do 1, but deliberately we think it's a best practice to think about systematically exploring sensitivity analysis as part of that, and the tool facilitates that process. But once we're there, we've got OHDSI 2019, best PLE ever. To give a sense that this is more than just a website with a form. Well, I'm going to put it on your desktop, I guess, if that's okay, Weaves. Okay. All right, we're going to put lots of junk. Oh, wow. Okay. But to give you a sense of actually what we're out of time, but to give you a sense of what you got, this zip file is in fact a full R package. What that means is that anybody who had access to an OMOP CDM can actually take this R package, upload it in RStudio, change 1 file in this package, whoops, called code to run. That's where you just specify your name of your database and the connection details so that you can talk to your database. And then once you build this package in RStudio, there's a function called execute. And you run the execute function, and it'll actually walk through all of the diagnostics and execute the study as Martijn and Weaves and Alex walked through with you. Importantly, as part of our best practices, the default, I think we've made it the default now, is that it does not actually look at the outcome until you choose to unblind yourself, meaning it'll run all of the diagnostics. You can make sure that you have a nice propensity score distribution, that you have adequate covariate balance, that you're feasible in terms of and adequately powered. And only after you have decided as a researcher that you feel good about your study would you unblind yourself to actually observe the effect estimate in the context of the negative controls. This example that we just went through, part of why we're not running it, we actually just did something that's interesting and hopefully leave you with the remarkable part about what we're doing in OHDSI, which is that you just designed a study without actually having access to patient-level data that could answer this question. And yet, we've designed a study that could run anywhere around the world. And what we would want to do is collaborate with others, say that Paul and Leanne, you have a good clinical idea. You have access to a tool that can facilitate you taking that idea from the piece of paper we started with to a design on a bigger piece of paper to an implementation that works. I don't know anything about lung cancer, but if we've gotten to the point that all I have to do is take a zip file and change 1 line of code in this thing and run it, then I'm happy to collaborate with you on your study. If you can tell me that it's important important for patients, then I can contribute as a data partner. And the power of what we're doing in OHDSI here is that now anybody with a good research question should be able to collaborate with anybody who's interested in the epidemiologic and statistical design of a study, who can then collaborate with anybody who has data, who wants to see that data go to good use. And by collaborating together, we could take this clinical idea, we've designed the study in 45 minutes, and if we want to make an open call to the OHDSI community, we could start getting results back tonight. Okay? That's the power of what we're trying to do as a community, and great testament to what Mark and Martine have actually built through this package, in addition to Senna and the team in making it available at OHDSI. Now that vision and that super cool idea, this is a reality that you guys all have access to right now. So we're at time, right? So I will shut up, but thank you guys for participating in our tutorial today. Any question?
When we get the zip file, could we bring back the new atlas platforms to
Yeah, great question, actually. And let me show that. I skipped over that, so I should have shown that. So that's right. So not only could I send someone a zip file so that they could run it in R to actually execute it, but in fact, just like I moved cohort definitions, I actually can take the JSON expression of this design, and I could just copy and paste this and say, hey, here's my design. What do you think about it? And I could go into my J&J instance, different Atlas instance, and I could actually just import that entire design. So every choice that Paul and Leanne just made is now in my J&J environment locally, and I'm now ready to not just run the study as the design is specified, but I could investigate this myself, and maybe if it didn't work or it wasn't feasible, I could do some work to figure out what tweaks do I have to make it work. And so these are all fully transparent and fully transportable elements. Okay. All right, one housekeeping thing, you're gonna receive an email right after this for a feedback form. We would really like to hear what you think went well and what didn't work so well for this tutorial. Second thing is we do these tutorials because we want to enable the community to do research. Our measure of success of whether or not it's worth doing these tutorials is that you all go do research and publish papers. And the way that we'll know that you are doing research and publishing papers is if you cite our papers so that we know that you're doing this work. So we have on the website, and it's in the book of OHDSI, recommended citations for Cyclops and for cohort method, and we recommend that you do studies and publish them in really top-tier journals so that we can be proud of you, and also cite our papers so that we can know that we're helping you enable your research. Any other administrative things? No? Okay. Any last questions? What's that? No cake smash. No cake smash today. All right. Thank you guys for putting up with us for the day. It's great to see you. Thank you for coming to the 2019 OHDSI Symposium, and look forward to collaborating with all of you moving forward.